Welcome to System Design Interview Crashcasts, where we dive into common interview questions for senior backend engineer positions. I'm your host, Sheila, and today we're joined by Victor, an experienced software architect. Victor, thanks for being here with us today.
Thanks for having me, Sheila. I'm excited to share my thoughts on system design with your listeners.
Great. Let's jump right in. Victor, here's today's question. Describe the differences between monolithic and microservices architectures. When would you choose one over the other?
That's an excellent question, Sheila. To start, let's define these two architectural styles. A monolithic architecture is a traditional model where all components of an application are tightly integrated into a single codebase and deployed as a single unit. On the other hand, a microservices architecture breaks down an application into smaller independent services that communicate with each other through APIs.
Thanks for that clear introduction, Victor. Could you elaborate on some key differences between these two approaches?
Certainly. The main differences lie in their structure, scalability, and deployment. In a monolithic architecture, all functions are managed and served in one place. This can make it simpler to develop and deploy initially. Microservices, however, are distributed, with each service responsible for a specific function and can be developed, deployed, and scaled independently.
That's interesting. What about the advantages and disadvantages of each approach?
Great question. Monolithic architectures are often simpler to develop and test, especially for smaller applications. They're also easier to deploy as a single unit. However, they can become complex and difficult to maintain as the application grows. Microservices, on the other hand, offer better scalability and flexibility. You can scale individual services based on demand, and it's easier to adopt new technologies or make changes to specific services without affecting the entire application. The downside is that microservices introduce complexity in terms of service communication, data consistency, and operational overhead.
Thank you, Victor. Now let's dive a bit deeper. Can you give us some specific scenarios where you would choose one architecture over the other?
Absolutely. I'd lean towards a monolithic architecture for smaller applications with a well-defined scope that isn't expected to grow significantly. It's also a good choice when you have a small team or are working on a proof of concept. Microservices shine in larger, more complex applications that need to scale. They're particularly useful for organizations with multiple teams working on different parts of the application. Companies like Netflix, Amazon, and Uber have famously adopted microservices to handle their large-scale distributed systems.
That's helpful context. Let's talk about scalability. How do these architectures differ in terms of scaling to meet growing demand?
Scalability is where microservices really stand out. With a monolithic architecture, you typically scale by replicating the entire application, which can be resource-intensive and may not address specific bottlenecks. In a microservices architecture, you can scale individual services based on their specific needs. For example, if your authentication service is under heavy load, you can scale just that service without touching the rest of the application. This granular scalability can lead to more efficient resource utilization and cost savings.
Interesting point about efficiency. What about performance and latency? How do these architectures compare in that aspect?
That's a great question, Sheila. In terms of raw performance, a well-designed monolithic application can actually have lower latency for certain operations because all components are in one place, reducing network calls. However, microservices can offer better overall performance at scale. While there might be some latency introduced by inter-service communication, this is often outweighed by the ability to optimize and scale critical services independently. Additionally, microservices allow you to use the best technology stack for each specific service, potentially improving performance.
Thank you, Victor. Now let's consider some edge cases. How do these architectures handle data consistency and transaction management, especially in a distributed environment?
Excellent point, Sheila. Data consistency and transaction management can indeed be challenging, especially in microservices architectures. In a monolithic application, Maintaining data consistency is generally simpler because you can use traditional ACID transactions within a single database. ACID stands for atomicity, consistency, isolation, and durability, which are properties that guarantee reliable processing of database transactions. With microservices, you're often dealing with distributed data and transactions. This introduces complexities like eventual consistency and the need for patterns such as the Saga pattern for managing distributed transactions. You might need to implement compensating transactions to roll back changes across multiple services if something goes wrong. It's important to carefully design your data model and service boundaries to minimize the need for distributed transactions. In some cases, you might choose to keep strongly related data within the same service to maintain consistency.
That's a thorough explanation, Victor. As we wrap up, could you share some best practices or current industry trends related to these architectures?
Certainly, Sheila. One significant trend is the adoption of a hybrid approach, often called a modular monolith. This approach tries to combine the simplicity of a monolithic architecture with some of the benefits of microservices. Another trend is the use of containerization and orchestration tools like Docker and Kubernetes, which can simplify the deployment and management of both monolithic and microservices architectures. As for best practices, regardless of the architecture you choose, it's crucial to focus on good design principles like loose coupling and high cohesion. For microservices, defining clear service boundaries and investing in robust monitoring and logging are essential. For monoliths, maintaining a clean modular codebase is key to preventing it from becoming unwieldy.
Thank you, Victor, for sharing your insights. This has been an incredibly informative discussion. To our listeners, remember that there's no one-size-fits-all solution in system design. The choice between monolithic and microservices architectures depends on your specific use case, team size, and scalability requirements. When answering this question in an interview, make sure to demonstrate your understanding of both architectures, their trade-offs, and the factors that influence the choice between them. Don't forget to mention real-world examples and current industry trends to showcase your up-to-date knowledge. That's all for today's episode of System Design Interview Crashcasts. Thank you for listening, and we'll see you next time.